Hi, Math 3 students. Mr. Eicher here, bringing the Chapter 5 Schoology review to you as a video so you can find which questions you'd like to go over, which questions you have questions about. So let's get started. Question 1 is you're given two functions, f of x and g of x. First, you're asked to add these two functions, f of x and g of x. So that just straight up is adding these two polynomials basically. So we would have 2x squared minus 3x plus 2. That's the f of x function. And we add that, I'll use a different symbol, a different color here. Add that to 2x minus 4. So now you can see which one's which. Got a little blue plus in there. And then adding like terms, the x's are like terms. The 2x squared doesn't have a like term. And then we have a negative x. And we have a negative 2. 2 minus 4 is negative 2. So that looks like it. Then next we have multiplying. And we've given you 4 spaces here to try to make it a little bit easier. You can get partial credit. Maybe you miss one term. You don't miss the whole thing, but just 1 out of 4 spots. But let's see if we can get this. When multiplying these, it might be good to set it up kind of like this so you can organize your work. So I'm going to put one function at the top, make a little table here. I'm going to put the other function as 2x minus 4, and then I'm going to multiply and fill in these spaces here. So I'm going to get 6 terms. Some of them are going to be like terms. So we get like this spot would be 2x squared times 2x is 4x cubed. And then we have 3x times 2x is negative 6x squared. And 2 times 2 is 4x. And then in the second row, we have negative 8x squared. We have a plus 12x. And we have a minus 8. And then adding like terms, we can kind of see these two are like terms. And then these two are like terms. So it looks like our answer would be 4x cubed. We have that negative 8 at the end. And then the like terms, we would have minus 14x squared. And we'd have a 16x. And the exponents go 3, 2, 1, 0. So the exponents are correct in standard form. And then next question, question number 2. We have two new functions, f of x and g of x. And first we're asked to subtract those two functions. Now be really careful when you're subtracting the two functions. You have the first function and then minus, do like that. The next function, x minus 3. And can you see where there might be a problem if you just leave it like this? If you leave it like that, it looks like you're only doing minus x. Really, it's minus this whole function. So you should put that in parentheses, and maybe that will let you know, hey, I need to distribute this negative to both of those terms. So it's really x squared minus 4 minus x plus 3. And that plus 3 is probably the most common mistake here. So our answer, we would have x squared, that's the first term, the biggest exponent there, and then a negative x, and then we would have a minus 1. Next, we're asked to do a composition of functions. Composition of functions is this notation, f of g of x. You could also see it written like this, f of g of x. And with this composition of functions, we're going to take the g of x function and we're going to plug it into the f function. So if we take the g of x function, this one, we're going to plug it into this x right here. So get rid of that x and put x minus 3. So it would look like this, x minus 3 squared minus 4. And then you just have to simplify that correctly. So be careful here. X minus 3 squared is going to be x minus 3 times x minus 3. I'll just write it up top here. That would be x squared minus 3x minus another 3x plus 9. So it looks like we'd get x squared minus 6x plus 9 minus 4. And subtracting the 4, that would be a 5. So it looks like our answer would be x squared plus negative 6x, and then 9 minus 4 is 5. And then the next part on number 2, we're going to do another composition of functions. Now we plug 3 into the f function and figure out what that is. So f of 3, plug 3 into the f function. So that would be 3 squared minus 4. So that's 5. And then once we have that, that basically represents this quantity right here, this thing right here. That's really a 5 now. So we're doing g of 5 now. And g of 5 would be 5 minus 3 using this g function, and we get a 2. So the answer to that third part there is 2. On to number 3. Number 3 states one function has a graph with these points. The inverse of the function has what points? Well, with an inverse, you swap the x and y. So we would have the points 2, 1, 4, 3, and 6, 5. That's it for that one. Next one, question 4 states, simplify this. You have 3 blanks to fill in. We gave you these little asterisks as multiply, just to make it a little easier to look at. And you're told that the first blank will have a numerical value and a variable part. So if we're doing the cubed root of 64, common cubed roots that are helpful to look for would be 1 cubed, 2 cubed, 3 cubed, 4 cubed. So can we write 64 as the cubed root of something? And well, actually, yeah, this one right here. So we could write 64 as 4 to the 3. So that means when we do a cubed root of 64, we would get 4. When we do a cubed root of x to the 6th, we take 6 divided by 3. That's x squared. The cubed root of y cubed, that would be a y. And then the cubed root of z to the 12th, that would be a z to the 4th. So we would type this as 4x squared. Notice the numerical part also has a variable part in that first blank. That's just a Schoology thing. And then we have a y, and we have a z to the 4th. Do we need absolute value signs? Absolute value anywhere? Well, we think of our even, even, odd. And do we have an even index? No, we don't. It's a 3. So from there, it doesn't matter the other questions. We do not need absolute value. So this would be our answer right there. Let's look at the next page, question number 5. It says to simplify this, and we have 4 options here. So let's see, how do these options compare? It looks like all of the numbers and variables are exactly the same. All the exponents are exactly the same. The only difference is the absolute value. So on this one, let's just think of our even, even, odd. Do we have an even index? Yes, it's 4. Do we have any variables that have even exponents? Yeah, this one and this one. So yes, we have a y to the 12th and we have a z to the 10th. Do we have any that end with an odd exponent? Let's see, this one ended with an odd exponent. So yes, y to the 3rd. So that tells us we need the y to the 3rd in absolute value bars. Now you might wonder, it's a good question, hey Mr. Riker, what about this one? This ended in an odd exponent, x to the 1st. Well, we don't really need to worry about that because originally it had an odd exponent, so it didn't match this even, even, odd. That would be what? Even, odd, odd. So we need to choose the answer where the y to the 3rd has absolute value bars around it. And let's look at question number 6. Question number 6, we have these square roots. We're going to use SQRT notation when we type it, and don't use spaces in Schoology. So when doing square roots, we're looking for perfect squares. So here are some common perfect squares. I'm not going to write them all. These should be pretty familiar to you, right? 1, 4, 9, 16, 25, 36. That should be enough. So we'd like to break these radicals into perfect squares. So square root 2 is just square root 2. 8 we can write as 4 times square root 2, because 4 is a perfect square, so we can square root it. And then 72 is the square root of 36 times 2. So 36 is a perfect square. And then we have 40 is 4 times 10. So basically we have a perfect square here, here, and here. So from there, we can square root, and we would get the square root of 2 plus 2 root 2 minus 6 root 2 plus 2 root 10. And then we would add like terms. All of these with the square root of 2 part are like terms. So this would be negative 3 square root 2 plus 2 root 10. And you can't add the root 2, root 10 terms. Those are basically different variables. You could think of them like you can't really combine these x and y because they're different. That's the same thing here. Square root 2 and square root 10 are different radicals, so you can't combine them. So this would be the answer in the blank. I'll pause there. That's about halfway through the assignment, and I'll make a second video in case you have questions from questions 7 through the end. Thanks for watching.